Welcome to Stay Sharp with Razor Leaf, your secret weapon for all things digital and products manufacturing. Hosts Jen Farello and Jonathan Scott are joined by Darrell Sabourin from iBase-t to explore the evolution of manufacturing work instructions. They dive into the shift from paper-based methods to digital systems, the rise of model-based engineering, and how 3D visual work instructions enhance shop floor efficiency. This conversation covers unique identifiers in 3D models, change management, and the transformative role of AI and additive technologies in shaping the future of manufacturing. Tune in for more insights on integrating these innovations for a smarter, more connected industry.
Welcome back, everybody, to Stay Sharp, the podcast about all things digital-related products and manufacturing. I am Jen Farello, and I'm joined today by my co-host, Jonathan Scott.
Hey, everybody.
And today we welcome back Darrell Sabourin. Darrell was one of our first guests on the podcast way back in episode 14, if you haven't listened to it, because that was actually before we had video. But go back and check it out. Darrell has spent the last 40 years in the aerospace and defense industry and is now putting all of that real-world, hands-on experience to work as the product manager for process planning at iBase-t. Ironically, he is also the bassist and lead vocals for Stone Country Band.
iBase-t, nice.
And I'm not kidding. Darrell is a true Renaissance man. And if you're interested in his complete bio, please do check out episode 14 because it is all there. But it's
Hello, everyone.
It's Darrell's industry experience that we're leaning into today with a look at how MBE, model-based engineering or model-based enterprise, has changed the process and tools that we use today in manufacturing execution systems. So welcome, Darrell.
Thank you very much for the intro.
So glad to have you back, Darrell. It's good to be talking about this topic again. I think, we definitely touched on it last time, talking about MES and model-based and touching on those topics. But I'm excited today to dig in and talk more about, work instructions, manufacturing process plans, and talking about how things are really different when we talk about a model-based world. So I guess to get started, we probably better talk about some of those terms and try and get them straight, and then dig into like, okay, what is different? How different is it, and what's that transformation, right? Because these things all used to be paper and manual processes. So let's start there. All right, what's a work instruction? What's a process plan? Maybe how they're different, how they relate, that kind of thing. Tell us your view of that.
Well, in my mind, they're kind of one and the same. Work instructions are how do I assemble this assembly, or how do I manufacture this part? Mm-hmm. A process plan encapsulates the work instructions and the routing. The routing is typically more of an ERP thing, where a routing has your work centers and your setup and run times, and that's how ERP establishes, what's the lead time on making this part or assembly. So a process plan has a bill of material associated to it as well. So all of those things, I guess you could say, become the work instruction on the shop floor. And that's where the rubber hits the road, is on the shop floor and building, whether it's building component parts or building assemblies. That's where the model is really changing the way things are done.
Let's back up there for a minute. For those who aren't familiar, people who maybe haven't been on the shop floor, that rubber meets the road part, the work instruction, if we go back to legacy, right, how things were, or for some people, how things still are, that work instruction could be a stack of paper, right? Something stapled together, 86 pages of step one, do this. Step two. Do I have the right concept there?
Absolutely. And, back in the day, you're right. They were printed out work instruction sheets. And if it was like for an assembly, it was probably put in a binder that was out in the work area. And, the technician or mechanic was flipping through pages of, a notebook, if you will. And, it was in plastic sleeves. And, whenever you made a change to the work instruction, there was a whole army of people that had to go out to these books and replace the paper with the new work instruction. And, that was the way that it worked back then. But
as compared to give us a view on what it looks like now.
Oh, today everything's electronic. Let's take that use case of I'm updating a work instruction. Well, I'm going to go into my process planning area and update the work instruction, make a revision to it, and then, like I know at iBase-t in Solumina, we have something called supersedes, where it'll allow you to revise the work instruction, and then it'll allow you to push that new revision out to all of the work orders that are on the shop floor. Because a work order today is a copy of the process plan.
Makes sense.
It's tracked in a different way, okay? Typically, a manufacturing engineer is going to be part-based, right? Everything's part number based in creating the work instruction. But then when a copy is made and it gets put out on the shop floor, it gets a work order number. And that work order number typically will come from the ERP system. And then the work that's being done is all tracked by the work order number, So
that you started off with a manufacturing process plan, sort of the template of how you're going to do it. And like you said, when you get the order, you instantiate that and say, okay, for this one, do it this way. And you've got then these work instructions that give you that step-by-step.
Correct. Point. There you go. There you go.
And as you were describing, that process that's still a little different today is if you had paper copies, you had to go out to that work instruction and replace the pages that change, that kind of thing. And now it's, because it's digital, not necessarily model-based yet, but digital, you can do that swap more easily somehow, right? You
Absolutely.
Can swap it overall for all the ones that you haven't done yet. That template can be swapped. And then maybe your software helps you control, okay, these are in process. Let me swap those in these certain ways. I imagine that's still tricky though, right, Darryl? I mean, if you've already done certain steps, that kind of thing?
Oh, it is. The code that was created for supersedes alone is very intense because of what you just said. You could have the revision 1 process plan out there in 10 orders, right? And each one of those orders could be at a different completion spot.
Right.
You may have already done operation 10 and 20 on 2 of them, and you may be down to operation 50 on a couple of them. And so that supersedes code is very complicated in that it has to take into account all of those situations.
Right.
Now, if no work has been performed on an order, it's pretty simple.
Yeah.
You just take revision 2 and you basically regenerate the work order with Rev 2. But if, again, you're at a certain spot of completion on all these others, then it becomes the difference between an entire scope replacement and a net scope. So,
and when you mention it's kind of simple. It's much simpler now, right? I mean, it used to be, to your point, you had to find all of the binders.
Oh yeah.
Take out the paper, make sure that, you put the corrections in, and make sure there's no rogue one back in the back shop that nobody remembered about, and they're still doing things the wrong way. At least from an update standpoint, you have some level of control, I'd imagine, over who gets to update the work instructions. Like Jack's not doing it different than Mary over here. So you have control over that. You can update it, and I think you said push it out to all of the different areas where it needs to be. So
yeah, I mean,
from a digital standpoint, that's helpful.
Before electronic digital, work instructions, there were tote boxes full of paper work orders, and even today, like, when I go through shop floors and do tours of shop floors, even today, there's that paper in the shop floor, and some of it might just be barcodes, right? There's paper out there now, but it's all barcodes. There's no work instructions associated to it at all. And what happens is they scan the barcode and it brings them right to the operation within the MES. And then they can start doing, performing the activities. So there's still paper on the shop floor. It's just nowhere near the amount that it used to be.
So that's one, I guess, evolution, right, of getting from the paper to digital. And even to your point, inside of digital, getting barcodes, getting things that make the process faster, help you connect better. But the thing we wanted to dig into today is, okay, well, let's talk about what's that next evolution, right? These are things that you're working on at iBase-t as you move toward being model-based. So what does model-based mean? How is that different in terms of this concept we're talking about with work instructions?
Well, it turns the whole environment into a dynamic environment. Whereas before, you may have had a screenshot of a certain page of the drawing maybe. Okay. And, that was part of the work instruction. You embed the graphic inside of the work instruction. Whereas with the model now, you've got a 3D representation of what you're building, and it's dynamic in that you can click on it, you can move it around, you can see different angles of, what you want to look at. And what we're doing with the model is even going one step further in that when the ME is creating the process plan or work instructions, our next release is going to have the ability to, where the ME can do all that twisting and turning of the model and zoom in on an area, like if it was a manufactured part, zoom in on a specific dimension that they want to control. Or if it's an assembly, zoom in on an area where you're putting a fastener in. And as the technician or mechanic goes through this and they click on that operation, the model zooms into where the ME had set the camera. Okay. So very dynamic. And then all the data collects that go along with that.
But before you get to data collects, I just want to sort of summarize what you just said, because it's a big deal what that changes. So from text and maybe a 2D picture, right, in our either paper or our legacy digital approach to work instruction, to dynamic 3D that's sort of guided by the ME, the person creating the instruction. But it's, well, let me ask, do you still have text? Do you still have written instructions? Or is it, no, I'm just going to show you. How does it work now?
I think it all depends on the assembly itself or the part that you're building.
Okay.
Visual goes a long way. And really,
we're all here.
Yeah, exactly.
Video on the podcast,
right,
visual goes a long way.
Yeah. But, when you're breaking down the process plan or work instruction, the thing that's going to give you the script to the video is the operations and the components that are allocated to those operations, or in the case of manufacturing a part, what dimensions am I creating at this operation? So now you have the script in the way that the process plan is created with these operations and components and data elements that you're creating. You can use that script, and now what you're really creating is a visual work instruction. Right. Because as the technician goes through each operation, he's visually being prompted now as to what he needs to do. And, my overall goal with, future releases is that once you've created the process plan and you've said, yay, verily, that's what I want to hit the shop floor, hit a button and you'll see the whole thing happen right in front of you from hitting one button. It'll take the script, the operations and components and dimensions, and it'll play it back to you. So that, for instance, if you have a new person on the shop floor and they've never built this assembly before, well, they pull the order up and hit the visual work instruction button, and they'll see the whole thing come together, 3D. And it's nothing different than, changing the oil on your lawnmower. You go to YouTube and you pull up a video and you watch somebody else do it. And then you go out in the garage and do it. And that's really my future view of where the model really, really is going to help the shop floor, in that give you that dynamic visual effect of what am I building and what do I need to do right now.
And it sounds like it's not necessarily completely defined or decided or standardized, and it probably shouldn't be, as this is all new to us, how much language goes along with it, right? The point is the visual communicates a ton. Maybe you have a little text that goes with it, or I don't know, like you said, if you turn it into a video, some audio that goes with it. But there may be some language in addition to the visual, but that's what we're driving to, right? Is so much more visual using these models.
Well, I mean, think about just the standard case that like everybody can identify with getting instructions for putting together furniture from IKEA. Mm-hmm. You know, I mean, if you think about it, like all of our instruction manuals for assembly used to have, well, it'd be in English, at least here in the US, and then it started being like, okay, it was in English and Spanish and French and Italian. Like, I mean, it's multiple instructions.
Right.
And we moved away from that. Arguably not a good move on the IKEA part, but like away from that to just pictures. But if you can take that step further, you know, and just move to purely video and 3D, it's something everyone can understand.
It is. And you know who's done a really nice job at it, believe it or not, is Lego.
Oh, yeah.
If you go on Lego, you can pull up 3D model assemblies of the Lego thing that you're building. And it shows all the parts coming together. I was amazed. Somebody had, when I started all the MBE stuff with, iBase-t and Solumina, this is my third trip doing this model-based stuff. One of my coworkers said, "Hey, have you ever gone to Lego and just, pulled up one of their 3D visuals?" And I'm like, "No, I haven't." So I did, and I sat back and I went, "Wow, not a single word,
right?
There, but it shows all the blocks coming together, flying in, and putting this together and the sequence of it, and that's what really started me thinking about process plan and how can I take the process plan and create that visual. So, we're working on that. And, each release, we get a little bit closer to that end goal of the visual work instruction. That's really where I want the 3D model to bring us to, is that 3D visual work instruction.
But I think that's a huge difference, right, in terms of how all of this operates. I mean, for those of us listening and kind of focused in on, okay, it was text, it was step one, and maybe a picture and some text, do this, do that. Step two, do this, do that, to switch to, now I'm just going to show it to you. I'm going to show the right parts at the right time, the new ones showing up, the old ones kind of in gray in the background or transparent or whatever it may be, right? With something visually cueing me what to focus on and what's changing, what's happening next. That's a big difference. And certainly in terms of ease of use of the user. But now let's talk about what that means in terms of change and the enterprise and all this data set, right? Darryl, why is this such a good idea from that other perspective?
Well, I think, with the 3D model, every part is a unique instance. Okay. So that, and the way that, it's being curated is through something called a universal unique identifier, a UUID. So you may have a pattern of 10 bolts, and each one of those bolts is torqued to a certain specification. And then they may even have a torquing sequence that needs to happen,
Right.
And all of that being in the model now, bringing it into the process plan. If I have those unique instances of those bolts, and I know what the torquing, the pattern is and what the values are, then I can leverage all that data that's in the model in my work instruction. And now I have even gone a little bit further in that each bolt instance, say one of them's not torqued to the right torque value. Well, that's a discrepancy, right? And in typically a discrepancy, you write a defect on it, and until that discrepancy is closed, that bolt, that one particular instance of the bolt, in my world is going to be red, because then when the operator looks at it, they know right from the jump that, hey, there's something going on with that particular bolt. And then you can drill into that and see that, oh, it wasn't torqued to the right spec.
You talked about two things there, right? There's sort of, I'm hearing a ton in that message about connecting back to that engineering data and that model and reusing the data from the model, right? And reuse, I think, is the key.
Yeah.
If we'd done that in language, we would have interpreted something, right? I don't know what it was. It probably would have been a note or some kind of specification in a document or something about that assembly that an ME would have read, understood, and interpreted, and then rewritten in a work instruction and a process plan and set up their steps. And there's that opportunity for a mistake, for confusion, whatever it is. Not just that, but then any change, you have to be cognizant of the translation that was done, right? When you decide, actually, the pattern needs to be different. Okay, in a model-based world, it's, it was 1, 2, 3, 4 in this certain order, and you just change the order. And now downstream, anybody who's reusing that gets the update. But in that sort of interpreted language world, it's, okay, what are they trying to change? What did they change about their instruction to me? And now how do I translate that to my instruction downstream? And that's just the first piece. That doesn't touch on what you were saying about now you get it wrong, you have to flag it, all that sort of thing. I mean, it's a huge difference.
It really is. And, think about impact analysis. Okay. When engineering makes a change, as long as they're keeping those UUIDs persistent in going from Rev A to Rev B, now I have a true change impact that I can run that says all of these UUIDs existed in A and all of these exist in B, but wait a minute, this one's gone and this new one shows up. So because of the UUIDs now, I've got an easy button, if you will, that says, here, go find me all the instances of this UUID in your work instructions, tell me where they are, and then replace them with this new one. And
that makes perfect sense, right? Your identifier has to be persistent in some way for you to get the tracing that you want for a good impact analysis. Like the example you gave a minute ago, your bolt that somehow got wrong, you turned it red. Okay, that may be straightforward enough on that one assembly and fixing it there. But let's say that you were working to work instruction and the part was Rev A, and somewhere in the background for another order, that part had turned into Rev B. And so there's some other work order active elsewhere. And because you learned what you learned to turn the part red, said, all right, I can't do that. Doesn't fit, whatever it might be. You want to go share that. Well, if there's an identifier that lets you connect what you're doing in that instance of that bolt and its identifier with Rev B over somewhere else, looks like a different part. We might not as humans connect it, but if the model can help us see that connection, that's a big deal. That's saving quality escapes. That's fixing problems. And it's doing it through the model.
It's a huge, huge deal. And take it one more step even beyond that. Okay. Now you've got the as built, okay, this is what the product looks like when it's going out the door. Think of an MRO situation. Now it comes back in the door and I've got to do maintenance, repair, and overhaul on it, sustainment. Well, as long as I know how it went out the door, I can then bring it back in the door and I already know what is sitting in front of me.
Right.
Because I've got that traceability record. And, because that there is going to be big time helpful to the MRO world and the sustainment world, in that, that's always been the biggest problem with MRO is that, they don't know what they've got until they've got it in front of them and they start tearing it down.
It's like home remodeling. So one thing I want to make sure that we don't lose, because, again, I have a very CAD centric background, and I want to make sure that everybody's realizing that we're not talking about a bolt that is instantiated, like basically and referenced multiple times we're not just talking about a bolt that's referenced a single bolt that's referenced 8 times, say in a particular assembly. We're talking about it's because that's reuse of data, right? So the part's defined, and then it's just said, okay, it's here, here, and here. But we're actually talking about those instantiations and any metadata associated with them. Correct? Like you were talking about like the torque or other characteristics.
Yeah.
So it's not, that's what makes it unique in that it is, or part of what makes it unique is that it carries all of that particular metadata for that particular space. So it's why you can say it's this bolt out of all of them that has that problem.
And that's the challenge, Darryl, that you're talking about with UUIDs and keeping all that straight. It's not a simple challenge because, Jen, to your point, it's not, oh, well, that bolt's part number blah. Of course, I've got an ID for it. Well, but it's bolt part number blah in location blah. And then, what if I revised it, but only revised certain one? It just gets complicated quick.
It does. And the UUID is something that the user never sees. Never sees.
Right.
It's in the
doesn't
background.
Want to either.
No, UUIDs are 36 characters long, and they're hexadecimal, segments of 8, 4, 4, and another 8, I think. You look at a UUID and you're going, well, that's the oddest number I've ever seen in my life. But no one needs to look at them as long as they're there, and you've set up your architecture that is going to save those for each object that's on the model, and save them throughout the entire manufacturing process, and then in the end be able to give them back to the PLM so that they can do more of their analysis. That's one of the things that I think that we need to get around. We need to get our arms around too. Is what system is good at what? What are their what's in their really their swim lane, if you will,
right?
And let them do that. If I have a PLM system and they can do simulations, God bless them. They can simulate the heck out of this assembly. But guess what? You can't use a simulation down on the shop floor.
Right.
You got to get it there. And that's where the MES world comes into play, And I've changed my thought process on this within the last couple of years. In that, I was always big on authoritative data source. Well, the process plan has to come from, Solumina,
single source of
MES, single source of truth, right? But with the advent of UUIDs and the data being all connected, I started pushing back on that with my own mind and saying, wow, geez, you know what? Let these PLM guys do all that. They're really good at it. They're really good at it. Let them do it. And in the end product of that is a model that should be really manufacturing ready, And if I'm going to take that model and bring it into Solumina, I'm not doing any measuring off of it. I'm not running any machines with it. I'm just using it as a pure visual. So it takes all the burden off of us too, in that, hey, we're just giving you the visual work instruction, and the engineering is the engineering, and it's all been vetted out, by all the simulations that have been done, because simulation's not only done on a part. If your factory is digital, the simulation is what machine is going to go through.
Right.
We used to have this problem all the time back when I was at Command Aerospace. We had a great machine shop. And, we had 3 identical machines, but they didn't run the same.
That's right.
Imagine that.
Identical.
They did not run the same. One was better at producing whole locations than the other. And, but we didn't know that back then. We just ran the parts through and they'd go over to inspection, and inspection would weed it all out. But if you had that data, about the machine and what the machine was doing, and again, digital factory, then you know that I can't put something this close tolerance on that machine.
So this is what you're talking about when you're talking about data collections, earlier.
Yes. Yeah. I mean, data collections are anytime you collect data, it's usable, it's mineable, it's,
Right.
it's valuable. And that's where the MES solutions come into play, is getting the work instructions down to the shop floor and collecting all the transactional data that happens down on the shop floor,
and hopefully connecting it back to the models, right, that were used for the visual work instructions. And that's your point about this identifier tying everything together. Because if you can't know that data you collected, to your point, was on the specific bolt that turned red that had the problem, then, how do you know back upstream to fix the design, to recheck the simulation, whatever it was? That's
Absolutely.
where this model-based world is so different.
It is. The digital thread that's talked about, God, there's all kinds of conferences going on and people standing up there and talking about the digital thread and how great it is in theory. I mean, a lot of it has been theory. And, we're finally getting to the point where it's matured enough where we can see that the value to it and we can use the value of it now. And getting it down to the shop floor is that's our focus. Our focus is, other systems do things that are great. Like, we'd never want to do ERP, right?
Who would want to do that?
Let them do that. God, we'd never want to control inventory. Why would we want to do that? Give it to the other system. We could never create a 3D model. So, let the engineering people have at that. And stitching it all together is the UUID. And that is truly the digital thread. It really is.
Yeah, certainly if we're going to use these 3D models, visual models to connect everything, we have to be able to identify all the things that you want to tie together if we're going to tie them together. And that's what you're getting at, right? And that's
absolutely,
that's the benefit of all this. When we talked at the beginning of the episode about, well, what is work instruction? What is the process plan? And talk through the text and how we've gotten to where we are, text and 2D. And, they're digital artifacts today, but maybe still made by hand and translated by hand. If we really want to get to the point of reusing this stuff, you have to be able to identify it to do that. And I think really that's, to me, is the theme of what we're talking about today and what we've come to.
It is. And but one of the biggest challenges that I see in the industry is that, models have been around for a long time. I mean, I can remember back in my command days where the machine shop guys, we had a couple of people that created the models, and then they created, the machine, how the machine was going to machine it. And then they'd print out this vellum tape, and then take the vellum tape down to the shop floor and run it through the reader on the machine. And just how far we've come with the models. But you're going to have a situation where you've been producing a product for the last 20 years using a model that was done 20 years ago.
Right.
And, its maturity level back then was nowhere near what a model is today. So you have a big challenge there, and you really got to sit back and think about it and go, I've been producing this part for 20 years. Am I going to really go back and redo that model to bring it up to today's standards? Or am I just going to let the sleeping dog sleep and keep producing parts? So all of this great UUID and digital thread, it's going to be a while. It's going to be a while before the industry has those models to that maturity, and all of these things that we're talking about come to fruition. It's going to be a while. It's not going to happen overnight. And I always think that when I see podcasts and videos of presentations that are done, and they're all talking about how this whiz-bang functionality, and I always sit back and roll back in my chair and go, yeah, okay, show me one of those models, please. Do you got one? Do you got one? So it's...
So between the two of you, I think that Jonathan, you just delivered a great summary of what we talked about, how far we've come, the value inherent in where we are, and how much further we can go. And then Darryl delivered fittingly it'll be a while. Basically, a hands-on view of it. Realize it's going to take some time, not just to get to the full value, which is continuing to grow probably on a weekly or daily basis, but just to get to where we're talking about now. I mean, we've all been in the industry for quite some time, at least I have. Mm-hmm. I can respectfully say that the move to 2D to 3D, from 2D to 3D, is not quite there yet. The drawings are still there. So for us to realize all of the value here, it will be a while. But
we'll be phasing it in for a while, right? I mean, I think that Darryl makes a great point that it's kind of the nature of manufacturing is, well, we design it and then we make 1,000 or we make 1,000,000 or we make however many, but we make more than one. And so if that's the case, you're going to be making things that you designed years ago. And so things that we think are great today, this great idea, it's just going to take a while. So I agree, Jen. I think that makes perfect sense.
Then you say things like that. I'm like, oh, what about additive though? Because additive changes the. Oh. But another time. Right? It's my job to keep an eye on time, and I don't want to start that thread right now.
Yeah, and I'll tell you one other conversation that we're probably going to be having, within the next couple of years is AI.
That's a good one.
And how does AI affect us? Right. I mean, I can see, an ME's job being affected by AI, in making it easier for one, where you could probably, in creating that process plan, say, hey, Mr. Chatbot, can you take part 1, 2, 3, 4, 5 and embed them into this work instruction? And it just happens, no fingers on the keyboard, no nothing, AI is going to be a game changer, I think, in a lot of areas.
This is a challenge of tech today, right? As soon as we got one good idea, model-based digital thread, and we can't even get that fully in place, guess what? Another great idea.
Yeah. And at the rate of AI, they'll be coming fast and furious.
Indeed.
Oh,
but
absolutely.
My job was to keep you guys on time, and here we are off on another topic. I'm going to suggest that maybe we have Darryl back and we talk about how AI is going to change work instructions or manufacturing planning.
Yeah.
Or additive or all the new tech, right? Yeah, I love it.
Additive. So, the other day somebody was talking about additive, and they also used the word subtractive. And I'm like, additive, well, of course, when you're machining something from a block of aluminum, you're subtracting, you're subtracting material. Right. I just thought it was a cool way of thinking about it. Everybody's talking about additive, and we're in a subtractive world today. So,
yeah, but it's changing. So, well, as soon as that hits the road, we'll have you back. We'll talk about additive manufacturing. We'll talk about AI, all of the changes that are coming.
Yeah, look forward to it.
We really enjoyed having you today, Darryl. And
another good conversation.
Yeah, leading to another good conversation.
And I so appreciate you guys and what you bring to the table, and just being able to talk about this is great. It's really is. These are the kind of conversations that need to happen. So that everybody starts understanding it.
That's a very good point. As a matter of fact, I'm going to kind of up my game on our sign off here and say, first of all, I will do the traditional stuff. I want to thank my co-host Jonathan Scott.
Absolutely.
And our guest, Darryl. It was a great conversation. But matter of fact, to Darryl's point, these are the conversations we want to be having. And we want, they're richer. The more people we have it in, the better. So we're into planning for next year. If you have a good idea, reach out to us. If you want to be on the podcast, reach out to us. Let us know. Because, we would love to talk to you. Conversation's much more interesting if you're in it. Reach out to us on social media, anywhere you find our podcasts. And until next time, stay sharp.
Thanks, everybody.
Thank you for being here and listening to this episode of Stay Sharp with Razorleaf. If you like this podcast, please be sure to hit the like button and subscribe to our podcast on your favorite podcast platform or on our YouTube channel. And if you have any comments or questions or want to contribute to our conversations, please leave us a comment on our post or send us an email to podcast@razorleaf.com. Until next time, stay sharp.